Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we'll be solving the 75th Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 75 is singular integer right triangles. It turns out that 12 centimeters is the smallest length of wire that can be bent to form an integer-sided right-angled triangle in exactly one way, but there are many more examples. And then it gives a bit of a list here. In contrast, some lengths of wire, like 20 centimeters, cannot be bent to form an integer-sided right-angled triangle, and other lengths allow more than one solution to be found. For example, using 120 centimeters, it is possible to form exactly 3 different integer-sided right-angled triangles. Then it lists those. Given that L is the length of the wire, for how many values of L less than or equal to 1,500,000 can exactly one integer-sided right-angled triangle be formed? Okay, so a couple of things to note here. One is, see how we have this 3, 4, 5, and then the next one is 6, 8, 10, and it's literally every number in the first line here times 2 is every number in the second line here. So this 3, 4, 5 is what is called a primitive Pythagorean triple, meaning it describes the smallest version of the right angle triangle that can be formed. With the given numbers. So, in other words, like 6, 8, 10 is just 3, 4, 5 times 2. So 3, 4, 5 is the primitive. And none of these numbers share a factor. And then 5, 12, 13 is another primitive here, as is 8, 15, 17. So our challenge, realistically, is finding first all of the primitive right-angle triangles. And then we can use multiplication to find all of the multiples of that parameter. So like all the multiples of 12 have a right-angle triangle in association with them. Also all the multiples of 30 and of 40. And of course there's a lot more, but I don't want to go through listing them. So if we go, I found this Wikipedia article on the tree of primitive Pythagorean triples. So I'm not going to read all of this, but the basic idea is we have these 3 matrices, and we can do a multiplication such that using these 3 matrices, we can do a multiplication which results in 3 different primitive Pythagorean triples based on the first one we give it. So if we start with 3, 4, 5, we get the triples, primitive Pythagorean triples of 5, 12, 13, 21, 20, 29, 15, 8, 17. And then, as you can see in the graphic here, it goes on indefinitely. So what we're going to do as a first step is we are going to find all these primitives. So let's copy our problem statement, go to VS Code, and then I'm going to copy my date time lines as I do. Okay, so our general strategy. Find primitive Pythagorean triples. I've been pronouncing that wrong. Then for each primitive, find the perimeter. Multiply the perimeter until limit is exceeded, counting along the way. It's a little bit harder to put into words than code, that one. And then go through perimeter dictionary, find all perimeters with one triple. Okay, so I am going to go ahead and throw our limit in here. I am going to start with a limit of 100 so that I can do some testing. Even 100 might be a lot, but we'll see. So first, whoopsies. I've copied this over. I had it set up in a separate screen. So what we want to do is, let's say, start equals 3, 4, 5. We want to start with the smallest one. They will continue to get larger. And then I'm actually going to do a find next triples that takes in I'm going to say a given. And then I'm going to do I think I can do this. I'm just going to call it I'm going to say A1, which is going to be A minus 2B plus 2C. Obviously, I have to have my multiplication symbols in there. And then B1 is 2 times A minus B plus 2 times C. C1 And there's probably a better way of doing this so that I don't have as many lines. But I'm just... Actually, I'm just going to do it that way. A2 equals... Oh, that's this formula down here. Why am I not just copying and pasting? I don't know. Okay, deleting these comments. This is going to be A3, B3, C3, and then I added my little multiplication symbols. And then what I actually want to have is up here, I'm going to have a primitives array, and I'm actually going to add start in the very first. Yeah. Now, let's just have it like that. And then primitives dot append A1, B1, C1, then actually it's going to be the same, except now the problem is that I have just created a completely infinite loop. So we want to come in here and we want to say if A plus B plus C is greater than limit, then we're just going to return. Okay, so then we call this find next triples with start. And then I'm just going to print primitives. And obviously this isn't going to give us the complete answer, but it should at least let us know we're on the right track. Okay, what if I do it like that? Okay, so here I have to add some more parentheses. Okay, so we can see we get this 3, 4, 5, and actually let's pull up that chart and we can kind of check our work. So we have our 3, 4, 5, 5, 12, 13, 21, 20, 29, 15, 8, 17. Then this column, 7, 24, 25, 55, 48, 73. Oh, and then it's 9, 40, 41. This one. And then we have the 9, 40, 41 went off. Okay. So it looks like we are on the correct track, at least. Which is very good to just have that assurance. So now we have that going. And then it says for each primitive, find the perimeter. So for primitive in primitives, key equals sum of primitive. I think this will work. And then while and I'm just going to say while new p less than or equal to limit, I have to create the it's going to be a dictionary. Parameter account dot set default. New p 0. And increment that by 1. New p plus equals p. And that should give us the complete count here. And then to find all the parameters with one triple, it is simple because we can just say print sum 1 for t in if. Okay, so that should give us an answer for the under 100. Okay, so we got 11, and we did get that almost instantly. I'm not 100% sure whether 11 is in fact correct. Hard for me to guess. I think this is correct for under 50, so let's throw limit of 50 here. Now we got 6, which is the same number as is here. So I think this is working. Let's do all of that. Okay, so we got 161,667. Let's see if that is the correct answer. There we go. Oh, and I've advanced to level 3. Cool. Cool. So here, I've actually attempted this problem several times. I have hours of footage of me trying to solve it. But the real trick here is being able to find the primitive triples in an efficient way. Because once you have that, then it's really easy to just be like, okay, let's go through and count all the parameters, and then go through the dictionary using a list comprehension inside of a sum call. That is all trivial stuff that you probably know how to do if you've done programming. I mean, this is a... List comprehensions, I think, might not be a thing in every language, but they are in Python. But you could do something quite similar in other languages, and it wouldn't be less efficient. So, cool. And then this is also a little bit of weirdness, where we're basically saying, okay, but split the iterable. So yeah, I'm going to call it there for that one. And if you would like my help with any code challenge you are working on, please check the link in the description. I'll see you in the next.